Hello, hello, and welcome to the Millionaire Millennial, the world's most powerful financial podcast. I'm your host, Stack Banks, and we're just going to get straight into it. So, for those of you who've been following along in this season 2 series, we're taking a deep dive into cryptocurrencies, blockchain, Bitcoin, those type of things, whatever you know them as, and we are actually going to do an advanced level introduction to what blockchain technology is. So first, what we'll do is we're going to discuss some basic concepts of distributed systems. What most of you would know as Bitcoin or blockchain or cryptocurrencies. And that's a broad term, distributed systems. And then what we did and will do throughout the series is review the history of blockchain. And then we'll discuss certain concepts such as electronic cash. And then we'll present various definitions of blockchains from different points of views. We'll also introduce you to a few of the applications of blockchain technology, and then we'll go on to explore different types of blockchain. And then finally, what we'll do is we'll examine the benefits and limitations of this new technology. And it's something that few topics such as blockchain scalability and adaptability issues were intentionally we will intentionally only introduce them briefly, and then as the series goes on, we'll hope to expand on them as they're relevant to you guys. But for those of you who are any type of savvy with cryptocurrencies or blockchain at all, a lot of you are probably already in the market or investing, but you don't really necessarily know what it is that you're investing in, right? You might know even what the project does or what it claims to do, but you're not really sure of the technologies behind it. So hopefully in this episode, we can cover some of those technologies and what makes up a blockchain or a distributed ledger or a smart contract, and being able to help you guys distinguish the difference between what all of those are and what that means. And maybe that will be something that will help you guys going forward into the future, because the crypto industry is here, right? Excuse me. The blockchain is not going anywhere, barring, a massive government shutdown or something like that. I personally believe that it's been around now for, I believe, going on 16 years. And the longer blockchain exists, the more we see its adoption by larger institutions and companies. And we're seeing it disrupt a lot of the traditional industries out there, right? So hopefully this is not meant to be taken as investment advice. Do your own research. Please do not take your money and start throwing it into projects that claim to do any of the things that you hear on this podcast without doing your own due diligence and your own research. And this is not meant to be taken as investment advice or you shouldn't consider this your research in its totality, right? A lot of the things that we talk about in this podcast, I briefly skim over, really, just to sort of give you guys starting points to deep dive into anything. And this podcast is not ran or endorsed by, sponsored by anything like that. Any companies other than itself, and we don't have any crypto investing partners or anything like that. So it's not something that it's my goal to push you towards any one project. I just want to make sure that you guys understand what these distributed ledger systems and blockchain technologies are, and potentially how they will impact, what projects you participate in, and also how the crypto industry and cryptocurrency as a whole may impact and affect your life. And if nothing else, if it's just something that you just want to take in as sort of a starting point for your own personal crypto education, please do that. But I would encourage all of you to pick up some reading. Specifically, there's a book by Imran Bashir that we reference specifically in this podcast. It's called Mastering Blockchain. And a lot of the things, excuse me, a lot of the things that we talk about on this podcast specifically come from this book and a number of other books that were written by people in this field. So that's my disclaimer. We will move on. So first, what we're going to do in this episode is sort of introduce a couple terms that you're going to hear in the distributed ledger blockchain world. They're very generic, and we will give them specific and general definitions here, and understand that not every blockchain or distributed system has all of this, or that all of these things will apply to each blockchain. But we're going to go over some very general terms that you're going to come across, and I would hope that the definitions of these will then allow you guys to make smarter decisions. So here's what the words are. So you're going to hear the term address quite a bit in blockchain. You're going to hear the term transaction. You're going to hear the term block. You're going to hear the term peer-to-peer network. You'll also hear scripting or programming language. You'll hear the term virtual machine, or Ethereum virtual machine, or chain virtual machine. You'll hear the term state machine. You'll hear the term node, and then you'll also hear the term smart contract. Okay, so let's dive into what these terms actually mean. So addresses are unique identifiers that are used in blockchain transaction to denote senders and recipients. An address is usually a public key or derived from a public key. While the addresses can be reused by the same user, addresses themselves are unique. In practice, however, a single user may not use the same address again and generate a new one for each transaction. This newly created address will be unique. Bitcoin is, in fact, a pseudonymous system. So end users are usually not directly identifiable, but some research in removing the anonymity of Bitcoin users has shown that they can be identified successfully. A good practice is for users to generate a new address for each transaction in order to avoid linking transactions to the common owner, thus preventing identification, if privacy is of utmost concern and importance to you. But that's what the term address is. So the address is essentially the public key or derived from a public key where you would send or receive cryptocurrencies. So another term we talked about, transaction. So a transaction is the fundamental unit of a blockchain. A transaction represents a transfer of value from one address to another. Okay? So a block, that's another term we talked about. A block is composed of multiple transactions and other elements such as the previous block hash or hash pointer. It's also known as a timestamp and nonce. So like I said, some of these terms we're just going to kind of gloss over and go back into at a later date in the series. I just want to give you guys a brief education on this stuff. So the other term, peer-to-peer network. So that's as the name implies, it's peer-to-peer network. It's a network topology wherein all the peers can communicate with each other and send and receive messages within the network. And then you'll hear the term scripting or programming language. So scripts or programs perform various operations on a transaction in order to facilitate various functions. So for example, Bitcoin transaction scripts are predefined in a language called script, which consists of sets of commands that allow nodes to transfer tokens from one address to another. So script is a limited language, however, so in the sense that it only allows essential operations that are necessary for executing transactions, but it does not allow for arbitrary program development. So think of it as a calculator that only supports standard pre-programmed arithmetic operations. So as such, Bitcoin script language cannot be called Turing complete. Some of you guys know what that means, but in simple terms, Turing complete language means that it can perform any computation. It's named after a guy, Alan Turing, who developed the idea of Turing machine that can, and Turing is spelled Turing for those of you who want to look it up, but Turing machine that can run any algorithm, however complex. So Turing completes languages, Turing complete languages need loops and branching capability to perform complex computations. Therefore, Bitcoin's scripting language is not Turing complete, whereas Ethereum's solidity language is. So to facilitate arbitrary program development on a blockchain, Turing complete programming language is needed, and it's now a very desirable feature of blockchains. So think of it as a computer that allows development of any program using programming languages. So nevertheless, the security of such languages is a crucial question and is essential and ongoing research area. So that's something we might talk about further on when we go into smart contracts and maybe developmental tools and frameworks of these blockchains, if that's something that we deep dive into. But that is what some of the definers right there when you look at the big difference between Bitcoin and some of the bigger names like we talked about Ethereum. Ethereum is Turing complete, right? So those of you who look at how future proof is Bitcoin, right, might be more inclined to look at Ethereum as an option as opposed to Bitcoin, right? So we'll keep going. I had mentioned the term virtual machine. So this is an extension of the transaction script that we had talked about earlier. So a virtual machine allows Turing complete code to be run on a blockchain as smart contracts, whereas a transaction script is limited in its operation. So, however, virtual machines are not available on all blockchains. Various blockchains use virtual machines to run programs, like we talked about, Ethereum virtual machine and Chain virtual machine. Ethereum virtual machine is used in the Ethereum blockchain, while CVM's Chain virtual machine is a virtual machine developed for and used in enterprise-grade blockchain called Chaincore. So another term we talked about, the state machine. So a blockchain can be viewed as a state transition mechanism whereby a state is modified from its initial form to the next one and eventually to a final form by nodes on the blockchain network as a result of a transaction execution, validation, and finalization process. So I'd said the word node. Some of you wonder what that means. So a node in a blockchain network performs various functions depending on the role that it takes on. So a node can propose and validate transactions, perform mining to facilitate consensus and secure the blockchain. This goal is achieved by following a consensus protocol, most commonly called a POW. Nodes can also perform other functions such as simple payment verification. Those are usually referred to as lightweight nodes. Payment verification, validation, and many other functions depending on the type of the blockchain used and the role assigned to that node. So nodes also perform a transaction signing function. Transactions are first created by nodes and then also digitally signed by nodes using private keys as proof that they're a legitimate owner of the asset that they wish to transfer to someone else on the blockchain network. This asset is usually a token or a virtual currency such as Bitcoin, but it can also be any real-world asset represented on the blockchain by using tokens. Okay. And then we had also talked about, or I guess I've introduced to you guys the term smart contract. So these are programs that run on top of the blockchain and they encapsulate the business logic to be executed when certain conditions are met. So these programs are enforceable and automatically executable. The smart contract feature is not available on all blockchain platforms, but it's now becoming a very desirable feature due to the flexibility and power that it provides to the blockchain application. So smart contracts have many use cases, including but not limited to like identity management, capital markets, trade finance, record management, insurance, and e-governance. And smart contracts we'll get into those as we continue this series. So what we're going to do real quick is just talk about how blockchain works, because we've defined and described blockchain, but we need to now see how blockchain actually works. So we introduced the term nodes. So nodes are either miners who created new blocks and mint cryptocurrency, you guys call them coins, or block signers who they're block signers who validate and digitally sign the transaction. A critical decision that every blockchain network has to make is to figure out which node will append the next block to the blockchain. And that decision is made using what's called a consensus mechanism. These consensus mechanisms we'll get into more than likely later on if I feel that's necessary to you guys. But what we'll do is we're just going to look at how a blockchain validates transactions and creates and adds blocks in order to grow a specific blockchain. So how blockchains accumulate blocks, we'll look at sort of like this a general scheme for creating blocks. The scheme that's presented here to give you sort of a general idea of how blocks are generated and what the relationship is between transactions and blocks. So firstly, a node starts a transaction by first creating and then digitally signing it with its private key. A transaction can represent various actions in a blockchain. Most commonly, it's a data structure that represents transfer of value between users on the blockchain. transaction structure, or excuse me, transaction data structure usually consists of some logic of transfer of value, relevant rules, source and destination addresses, and other validation information. And we'll get more into the specifics of that when we talk about Bitcoin and Ethereum later on in this series. And then secondly, a transaction is propagated or flooded by using a flooding protocol. There's one called Gossip Protocol, and it's propagated to peers that validate the transaction based on preset criteria. Usually more than one node are required to verify that transaction. And then once the transaction is actually verified, it's included in a block, which is then propagated onto the network. And at that point, the transaction is considered confirmed within the network. So after that, though, the newly created block now becomes part of the ledger, and the new block links itself cryptographically back to this block. That link is a hash pointer. And at this stage, the transaction gets its second confirmation and the block gets its first confirmation. Transactions are then reconfirmed every time a new block is created. Usually 6 confirmations in the Bitcoin network are required to consider the transaction final. So it's worth noting that steps 4 and 5 are considered non-compulsory, right? Or non-compulsory. So as the transaction itself is finalized in step 3, however, the block confirmation for the transaction reconfirmations are required, and they're carried out in step 4 and 5. But that's basically at step 3, it's done. So we talked about just a basic introduction of what is blockchain. And then in the next section, we'll learn about just sort of some of the benefits and limitations of this technology, right? Because there's numerous advantages to blockchain technology, and they're being discussed in industries the world over, being proposed by thought leaders around the world, people who are actively participating in the blockchain space. So some of the notable benefits of blockchain technology that we'll talk about. So number one, a lot of people are super excited about is just the decentralization. So what does that mean? So this decentralization is a core concept and benefit of the blockchain. There's no need for a trusted third party or intermediary to validate transactions. Instead, like we talked about, a consensus mechanism is used to agree on the validity of those transactions. And then transparency and trust, because blockchains are shared and everyone can see what is on the blockchain. Excuse me. This allows the system to be transparent, and as a result, trust is established. This is more relevant in scenarios such as the disbursement of funds or benefits where personal discretion in relating to selecting beneficiaries needs to be restricted. Okay. And then you have immutability. And once data has been written onto these blockchains, it's extremely difficult to change it back. It's not, most of them, truly genuinely immutable, but because changing data is so challenging and nearly impossible, it's seen as a benefit to maintaining immutable ledgers of transactions. And then you have the high availability of blockchains. It's a system that's based on thousands of nodes in a peer-to-peer network, and the data is replicated and updated on every node. The system becomes highly available. Even if some nodes leave the network or become inaccessible, the network as a whole continues to work, thus making it highly available. And it's, super beneficial to most users. And then on top of it, it's highly secured because all the transactions on a blockchain are cryptographically secured, and that provides network integrity. And then all of this also allows for simplification of current paradigms, because the current blockchain model in many industries such as finance or health is somewhat disorganized. In these models, multiple entities maintain their own databases, and data sharing they maintain their own databases, and data sharing can become very difficult due to the disparate nature of the system. However, as a blockchain, it can serve as a single shared ledger among many interested parties, and that can result in simplifying the model, thus reducing the complexity of managing the separate systems maintained by each entity, right? And then it's just faster. In the financial industry, especially in post-trade settlement functions, blockchain can play a vital role by enabling the quick settlement of trades. Blockchain doesn't require a lengthy process of verification and reconciliation and clearance, because a single version of agreed upon data is already available on a shared ledger between financial organizations. And I believe what is probably of most interest to most of these businesses is the cost saving. because you have no trusted third party or clearinghouse. There's none required in the blockchain model, and that can massively eliminate overhead costs in the form of fees, which are paid to parties. So, as with any technology, some challenges need to be addressed in order to make a system more robust and useful and accessible. And blockchain technology is no exception. In fact, there's a lot of effort being made in both academia and the business industries across the world to overcome the challenges posed by blockchain. And we'll talk about some of those as time develops. I mean, we're going on about 20 minutes now, but quickly I'll touch on that. And you run into the issues of scalability, adaptability, regulation, between the markets and governments around the world. The fact that blockchain, is still a relatively immature technology, and then the issue of privacy amongst users and the entities that seek to use these things. So we're going to talk about all those things here in the future, but I just want to give you guys a couple just quick pointers and things to consider when you're looking at these blockchains and these projects before you guys actually go put your money into them or see if it's something that's worth your time. Please be sure that it's something that falls within these categories, that it has some of these features, if not all of these features, and hopefully that will keep you guys in the right path of being able to distinguish whether some of these projects are legitimately ran by people who want them to see the future and go forward in the future, or they're just meme coins, altcoins, scam coins, things like that. Like I said, please do your own research. But we're coming up right now on 22 minutes for this podcast, and I'll cut it there. But please follow us, the Millionaire Millennial Podcast. We're on Spotify. We're gonna be on Apple Music soon, I believe, and Pandora, Spotify, Apple Music, and follow us on Instagram as well. We'll be updating when the latest episodes come out, always on there. And then please look forward to future episodes. We're going to have a couple different CEOs on this year of some very large corporations, some guys who are massive thought leaders. And I won't reveal the names just yet, but it should be some very exciting stuff. So please, you guys, take care of yourselves, make smart investments, save your money, and tune in to the Millionaire Millennial, the world's most powerful financial podcast.